Hello students, how are you all? Okay, thank you. This is our next topic. Basically, in concave mirror or in spherical mirrors, there are some terms are there. First, you have to understand these terms. Then only it is easy for us to go through all the things about spherical mirrors. Basically, these are the main terms. In this, the first term, pole, center of curvature, radius of curvature, principal axis or principal focus and focal length. Okay, like this we have explained here. First, we will discuss one by one by taking a diagram here. First of all, what is a pole? First, you consider a spherical mirror like this. This is what we have, a spherical mirror. Spherical mirror means a mirror which is a part of a sphere. Which is a part of a sphere. This is a sphere in which this mirror is a part. Suppose if you consider a concave mirror, then it is polished outside. It is polished outside. And the reflection of light will take place inside. Okay. First, what is the first one? Pole. What is the meaning of a pole? Pole is nothing but it is the center of a spherical mirror. Means this is a mirror in which the center, where you have to consider the center, this is what we have, a center. And this center we are calling it as a pole. Pole is nothing but a center of a mirror. Center of a mirror. This is what we have, a pole. Okay, that is our first one. What about second one? Center of curvature. Center of curvature is nothing but the normal from a concave mirror converge at a point. That is one definition is there. We will discuss. But basic definition is center of curvature is nothing but the center of a sphere. Center of a sphere. This is sphere at which this is our center. That's why this we are calling it as center of curvature. Center of curvature is nothing but the center of a sphere in which mirror is a part. Mirror is a part. That is one definition we explained here. What is center of curvature? Center of curvature is nothing but center of a sphere in which mirror is a part. Another definition, the normal from the concave mirror converge at a point. Suppose you consider this is a normal and this is a concave mirror in which if you draw a normals like this. If I want to draw a normal, this is a normal. Okay, this is what we have a normal. This is what we have a normal. If all these are converging, okay, like this. If all these are converging at one point, then that is also we are calling it as a center of curvature. Center of curvature means all the normals converge at one point. Okay, if you draw like this, all the normals are converging. See, you observe it. All the normals are converging at one point. If all the normals are converging at one point, that is also we are calling it as center of curvature. Center of curvature, or center of curvature is nothing but center of a sphere in which mirror is a part. That is also one of the definition. Okay, this is what we have, center of curvature. What is the next one? Next one, radius of curvature. What is a radius of curvature? Radius of curvature is nothing but one of the definition is the distance between pole and center of curvature. Okay, the distance between pole and center of curvature. This is pole and center of curvature. This is what we have, radius of curvature. Okay, this is what we have, a radius of curvature. Radius of curvature is nothing but the distance between C and P. C and P. Or another definition, what is the basic definition? Radius of curvature is nothing but it is also a radius of a sphere in which mirror is a part. Like we have discussed in center of curvature, radius of curvature can also be defined as the radius of a sphere in which mirror is a part. or the distance between C and P, that is also we can call it as radius of curvature. What is the next definition? Another definition we can also explain here. Can I write here? Okay, last another two definitions are there, we will discuss. One more definition is the line passing through, the line which touches C and P. Okay, the line which touches C and P, and this we are calling it as principal axis. Okay, principal axis. What is a principal axis? Principal axis is nothing but a line which is passing through C and P. Okay, C and P, that we can call it as principal axis. I will write here principal axis. Principal axis means, what is principal axis? The line passing through, C and P. C and P is called principal axis. Okay, we will write principal axis. Okay, this is what we have. What is the next one? Principal focus. We have discussed pole, center of curvature, radius of curvature, principal axis. This is principal axis. Another one, principal focus or focal point. Like this we have so many names are there. What is the principal focus here? The rays coming from the distant object parallel to a concave mirror will converge at a point, and that we are calling it as a focal point. Means, suppose you can take a line. Suppose here we have, because when the object is at long distance, infinite distance, how the rays are coming? The rays must be parallel to the principal axis. All the rays are parallel to the principal axis. Like this, all the rays are parallel to principal axis. After reflection, they converge at one point. Like this, they converge at one point. This is what converging point, and this converging point we are calling it as focus, principal focus or focal point or focus, and that can be represented with the letter capital F. Okay, capital F is there. Suppose you take one more ray parallel to principal axis, after reflection they will meet it, they will converge like this. Okay, they will converge like this. All the rays are parallel to the principal axis, they will converge at one point, and this point we are calling it as focal point. Okay, one more definition, and last definition here we have focal length. What is a focal length? How we define the focal length? Focal length is nothing but, and focal length can be represented with small f. Okay, focal length can be represented with the letter small f. And how we define focal length? Focal length is nothing but, it is the distance between, okay, it is the distance between C and F or F and P. Okay, F and P or C and F, because you know this total is R. That's why here the distance between C and F, okay, or we can also write P and F also, or F and C, or pole P and, okay, focus. focus. Okay, like this. And here you can observe it. This one is also f and this one is also f. Total here to here is r. That's why we can write r must be equal to 2f. Total is radius of curvature, and radius of curvature is nothing but double the focal length. Or if I want to represent f is equal to r by 2. F is equal to r by 2. This is what we have the relation between f and r. F and r. Focal length is nothing but half of the radius of curvature. Okay, this is the what we have. There are some terms related to spherical mirrors. Okay, just copy this one. We will discuss one more topic here, and the topic is the differences between real image and virtual image. Okay, shall I rub now? Okay. What is a real image and what is a virtual image? That we have to discuss here. Already we know the real image and virtual image. What is a real image and virtual image? This is what we have, a real image, and here we have virtual image. Real image and virtual image. But simply we have to differentiate these two, because these are very important for public exam. Especially we have to find out the differences of real image and virtual image. Okay, what is a real image? Real image means, simply by definition we can say that the image which can be brought upon a screen. Okay, screen paina choose vaatini manam real image antam. The image which can be caught upon a screen, and that image we are calling it as real image. Or we can say that the light rays after reflection or after refraction, they converge at one point. They converge at one point. Just now we have seen in the case of focal point. What happens? After reflection from the surface, they converge at one point, and that image, whatever the image formed at that point, is called as a real image. Okay, just we have to write the differences here. The first difference we can write, real image is formed. Real image is formed. Real image is formed if light ray after reflection in case of mirror or refraction in case of lens. Refraction. Real image is formed if light ray after reflection or refraction converges at a point. Converges at a point. And this is called as real image. What about virtual image? Virtual image is the image, it appears to diverge from a point, or it appears to come from a point. ఒక పాయింట్ నుండి వెళ్ళినట్టుగా కనబడుతుంది. ఓకే, and that image we can call it as a virtual image, that we discussed in convex mirrors. In the case of convex mirrors, how it will be means, this is a convex mirror. Okay, this is what we have, a convex mirrors. Suppose when a ray is there like this, when a ray parallel to principal axis, after touching it will be moving like this. Okay, when the ray coming like this, after the polishing is outside, polishing is like this only. Okay, it will reflect like this, and all these points are, they appears to come from the point. ఈ పాయింట్ నుండి వచ్చినట్టుగా కనబడుతుంది. కాబట్టి ఇటువంటి ఇమేజ్ ఏదైతే ఉందో, దాన్ని మనం వర్చువల్ ఇమేజ్ అంటాం. ఓకే, వర్చువల్ ఇమేజ్ మీన్స్ ఇట్ ఈస్ ఫార్మ్డ్, ఇట్ అపియర్స్ టు కమ్ ఫ్రమ్ ద పాయింట్. virtual image virtual image is formed. Virtual image is formed when rays after reflection appears when rays after reflection appears to be come from a point. This is what we have virtual image. Like this we have two images, real image and virtual image. Already we have seen some cases. In that cases we discussed where should be the real image is formed and virtual image is formed. Okay, this is what we have two differences. Another here how the rays are actually meeting, here appears to come. That's why here the rays are actually meet at the image point. Okay, this is what we have one more difference. Actually meeting, but here appears to come. Here the rays are here the rays are appears to diverge from image point. అంటే పాయింట్ నుండి వెళ్ళినట్టుగా కనబడుతుందిగా, ఇందాక మనం చూసాం. ఇట్ అపియర్స్ టు డైవర్జ్. ఓకే, it appears to diverge like this. This is a surface, polishing surface. The rays are like this, they move away. Here the rays are coming like this, they move away. This is a principal axis. How they are? They appears to diverge. Okay, they appears to diverge from a point, and this is what we have, the diverge from the image point. This is what another difference. Okay, third one, already we have seen that where the image is formed at the screen. That's why it can be brought upon a screen. Okay, it can be brought upon a screen, and here it cannot be brought upon a screen. Already we have seen in the case of plane mirrors, daily we are seeing now our face, and that image is a virtual image, and we cannot brought upon a screen. Okay, that is what we have another case here. Okay, and in this case the real image is always inverted. It is always inverted. Mostly 99.9% all images are inverted. Only some particular cases we observed. In cases we have obtained erected images. The last case, in the case of concave mirror, we have seen in the sixth case. In the sixth case it is erected image. Okay, that we observed here. But almost in the case of this real image must be always inverted only. Only virtual images are erected. In the sixth case what we explained there, okay, that is erected image. That's why it is always erected. It is always erected. అందుకే మనం సిక్స్త్ కేస్లో ఎరెక్టెడ్ ఇమేజ్ ఫామ్ అవుతుంది. ఇందులో కాన్కేవ్ మిర్రర్లో వెన్ ద ఆబ్జెక్ట్ ఈజ్ బిట్వీన్ ఓకే ఎఫ్ అండ్ పి, ఆ కేసులో మనం చూసాం ఇట్ ఈస్ ఎరెక్టెడ్ మ్యాగ్నిఫైడ్ ఇమేజ్. ఓకే, దిస్ ఈజ్ వాట్ వీ హ్యావ్ differences between real image and virtual image. Okay, just to write this one, copy.